The title of this book differs by only 2 letters from that of a book first published in 1988. A Brief History of Time was on the London Sunday Times bestseller list for 237 weeks and has sold about 1 copy for every 750 men, women, and children on Earth. It was a remarkable success for a book that addressed some of the most difficult issues in modern physics. Yet those difficult issues are also the most exciting, for they address big, basic questions. What do we really know about the universe? How do we know it? Where did the universe come from? And where is it going? Those questions were the essence of A Brief History of Time, and they are also the focus of this audiobook. In the years since A Brief History of Time was published, feedback has come in from readers of all ages, of all professions, and from all over the world. One repeated request has been for a new version, one that maintains the essence of a brief history yet explains the most important concepts in a clearer, more leisurely manner. Although one might expect that such a book would be entitled A Less Brief History of Time, it was also clear from the feedback that few readers are seeking a lengthy dissertation befitting a college-level course in cosmology. Thus, the present approach. In writing A Briefer History of Time, we have maintained and expanded the essential content of the original book, yet taken care to maintain its length and readability. This is a briefer history indeed, for some of the more technical content has been left out, but we feel we have more than compensated for that by the more probing treatment of the material that is really the heart of the book. We have also taken the opportunity to update the book and include new theoretical and observational results. A Briefer History of Time describes recent progress that has been made in finding a complete, unified theory of all the forces of physics. In particular, it describes the progress made in string theory and the dualities or correspondences between apparently different theories of physics that are an indication that there is a unified theory of physics. On the observational side, the book includes important new observations, such as those made by the Cosmic Background Explorer satellite, COBE, and by the Hubble Space Telescope. Some 40 years ago, Richard Feynman said, "We are lucky to live in an age in which we are still making discoveries. It is like the discovery of America. You only discover it once." The age in which we live is the age in which we are discovering the fundamental laws of nature. Today, we are closer than ever before to understanding the nature of the universe. Our goal in writing this book is to share some of the excitement of these discoveries and the new picture of reality that is emerging as a result. Thinking about the universe. We live in a strange and wonderful universe. Its age, size, violence, and beauty require extraordinary imagination to appreciate. The place we humans hold within this vast cosmos can seem pretty insignificant, and so we try to make sense of it all and to see how we fit in. Some decades ago, a well-known scientist, some say it was Bertrand Russell, gave a public lecture on astronomy. He described how the Earth orbits around the Sun and how the Sun, in turn, orbits around the center of a vast collection of stars called our galaxy. At the end of the lecture, a little old lady at the back of the room got up and said, "What you have told us is rubbish. The world is really a flat plate supported on the back of a giant turtle." The scientist gave a superior smile before replying, "What is the turtle standing on?" "You're very clever, young man, very clever," said the old lady. "But it's turtles all the way down." Most people nowadays would find the picture of our universe as an infinite tower of turtles rather ridiculous. But why should we think we know better? Forget for a minute what you know, or think you know about space. Then gaze upward at the night sky. What would you make of all those points of light? Are they tiny fires? It can be hard to imagine what they really are, for what they really are is far beyond your ordinary experience. If you are a regular stargazer, you have probably seen an elusive light hovering near the horizon at twilight. It is a planet, Mercury, but it is nothing like our own planet. A day on Mercury lasts for 2/3 of the planet's year. Its surface reaches temperatures of over 400 degrees Celsius when the sun is out, then falls to almost -200 degrees Celsius in the dead of night. Yet as different as Mercury is from our own planet, it is not nearly as hard to imagine as a typical star, which is a huge furnace that burns billions of pounds of matter each second and reaches temperatures of tens of millions of degrees at its core. Another thing that is hard to imagine is how far away the planets and stars really are. The ancient Chinese built stone towers so they could have a closer look at the stars. It's natural to think the stars and planets are much closer than they really are. After all, in everyday life, we have no experience of the huge distances of space. Those distances are so large that it doesn't even make sense to measure them in feet or miles, the way we measure most lengths. Instead, we use the light year, which is the distance light travels in a year. In 1 second, a beam of light will travel 186,000 miles, so a light year is a very long distance. The nearest star, other than our Sun, is called Proxima Centauri, also known as Alpha Centauri c, which is about 4 light years away. That is so far that even with the fastest spaceship on the drawing boards today, a trip to it would take about 10,000 years. Ancient people tried hard to understand the universe, but they hadn't yet developed our mathematics and science. Today we have powerful tools, mental tools such as mathematics and the scientific method, and technological tools like computers and telescopes. With the help of these tools, scientists have pieced together a lot of knowledge about space. But what do we really know about the universe, and how do we know it? Where did the universe come from? Where is it going? Did the universe have a beginning, and if so, what happened before then? What is the nature of time? Will it ever come to an end? Can we go backward in time? Recent breakthroughs in physics, made possible in part by new technology, suggest answers to some of these long-standing questions. Someday these answers may seem as obvious to us as the Earth orbiting the Sun, or perhaps as ridiculous as a tower of turtles. Only time, whatever that may be, will tell.